Imagine gazing into a mirror that doesn't just bounce back light, it reflects time itself. But instead of your own reflection, you're staring into the newborn moments of the cosmos, when reality was just beginning to inhale its very first breath. That, in essence, is the purpose behind the James Webb Space Telescope. But what it uncovered, peering further than anything before it, wasn't a glimpse into cosmic infancy. It wasn't the universe's nursery. It was a paradox, an impossibility that defied every assumption. What Webb discovered didn't just astonish astronomers, it rattled the very foundation of modern physics. For generations, scientists were confident in their understanding of cosmic evolution. The Big Bang, followed by a long darkness, then a slow, deliberate emergence of stars, galaxies, and ultimately, life. The farther back we looked, the simpler. Things were supposed to be elementary particles, sparse hydrogen clouds, disorganized, chaotic space. But when Webb aimed its golden mirrors at a distant, supposedly quiet region of the sky, an expanse where we expected little more than blackness, it revealed something that shouldn't have been there at all. A fully formed galaxy. Not a vague smear or loose cluster of gas, but a complex rotating system of stars, complete with spiral arms and a supermassive black hole at its core. Not only had it formed, it was flourishing. And it wasn't a one-off. As more data streamed in, more of these ancient galaxies appeared, structured, chemically rich, gravitationally mature. It was as if the universe had skipped billions of years of development and leapt straight into an era of impossible sophistication. With each new discovery, a disturbing question grew louder. What if everything we thought we knew about the universe's beginning is wrong? When Webb first captured an image of what should have been a dim, ancient blur over 13 billion light-years away, scientists expected the usual a faint glimmer barely above background noise. But what stared back was architectural brilliance. Spiraled arms glowing like starlit ribbons, compact star clusters orbiting with precision, and a dense, energetic core. This galaxy wasn't in the process of forming. It was already finished. And not just barely. It looked like something that should have emerged billions of years after the Big Bang, not within a few 100 million. To understand how deeply this unsettles astrophysics, you have to understand how galaxies are expected to form. In the early cosmos, matter was thin and clumpy. Gravity slowly gathered it into clouds, which collapsed into stars. Over immense time, those stars grouped into galaxies. But Webb's observations suggested that this entire sequence had already unfolded, and far too fast. That galaxy hadn't just appeared, it had thrived. Our physical laws don't permit this. It's like finding a towering redwood tree sprouting overnight in freshly tilled soil. Even stranger, this wasn't rare. Webb uncovered many such examples, galaxies all across the sky, displaying levels of order, richness, and maturity that current models insist are impossible. And it wasn't the telescope malfunctioning. The instruments were flawless. What failed was the theory. When astronomers analyzed the spectral data, the light signatures revealing a galaxy's composition, they were struck again. These galaxies didn't just exist. They carried chemical fingerprints of elements that, by all logic, shouldn't be there yet. Oxygen, carbon, even iron. Such elements are forged in the cores of massive stars and only released during their explosive death supernova. That takes time. First-generation stars, population 3, burn hydrogen and helium. When they die, they scatter elements that fuel the next generation. This entire sequence should span hundreds of millions, if not billions of years. Yet here were galaxies, under 400 million years old, showing signs of multiple stellar generations. Meaning, not only had the first stars formed and died, but their successors had already emerged. The early universe wasn't gently stirring it. was roaring, fusing, collapsing, and igniting with an urgency no one foresaw. The presence of these heavier elements brings an even deeper mystery. Because they don't just make stars, they build planets, atmospheres, and potentially life. Finding them so soon is like stumbling across a thriving coral reef in the wake of a volcano that erupted yesterday. The timeline isn't just accelerated, it's shattered. And came the most jaw-dropping revelation. At the center of one of these ancient galaxies, astronomers found something inconceivable. A supermassive black hole, estimated at over 1 billion times the mass of our sun. In today's universe, that would be remarkable. But in the early universe, it's borderline absurd. Black holes, as we understand them, begin as remnants of dead stars and grow slowly accreting. Gas and dust over eons. Even the most extreme growth models can't explain how such a titanic black hole could emerge within just 400 million years. It would be like discovering a fully grown adult who was born an hour ago. The math simply doesn't hold. And yet there it was. Its gravitational influence was unmistakable. The surrounding star's orbits, the radiation it emitted, the warped space around it all confirmed its presence. It hadn't grown. It had arrived. This forced scientists to entertain radical ideas. Perhaps primordial black holes were born directly from ultra-dense fluctuations in the early cosmos. Or maybe unknown particles or dark matter accelerated their birth. But these aren't tweaks to existing models. They're a complete rewrite of reality's blueprint. What do you do when every new observation breaks the rules you trusted? For many cosmologists, the only answer is unsettling. You rewrite the rules. Because Webb hasn't just shown us weird outliers. It's unveiled a universe that seems to run in reverse, where complexity precedes simplicity, and where ancient light carries information that has no business existing. Some theorists now propose that dark matter, long assumed to be passive, may have aggressively shaped the early cosmos, forming invisible scaffolds that fast-tracked galaxy formation. Others suggest time itself may have behaved differently, stretched or twisted in ways we can't yet measure, allowing ages of evolution to play out in what appears to us as mere moments. And then there's the most unsettling theory, that the early universe was never all that different from what we see today. That maybe, just maybe, complexity wasn't the destination of cosmic growth. It was the starting point. As the telescope continued to gather data, scientists noticed something stranger still. Not in the brightness of the galaxies, but in their shapes. Using deep learning algorithms, they found that these ancient galaxies followed a particular, repeating mathematical pattern, eerily close to the golden spiral. This wasn't just beautiful, it was structural. A hidden geometry linking galaxies across billions of light years in a fractal symmetry, suggesting the cosmos might have been organized from the very beginning. The spiral arms, the balanced rotations, the elegant orbits. Webb's high-resolution imaging showed us that the early universe wasn't chaos. It was patterned, predictable, like fingerprints. But fingerprints of what? A deeper natural law, or something more disturbing. A hint of intentionality woven into space-time itself. And then came one of Webb's most controversial discoveries, not in a galaxy, but in a quiet stretch of space assumed to be barren. In this ancient void, Webb's instruments detected something mind-bending, complex organic molecules. Not just basic chemicals like methane, but polycyclic aromatic hydrocarbons, the building blocks of amino acids, and thus of life. These molecules weren't clinging to planets. They weren't floating in stars. They were just there, drifting for over 13 billion years intact. This shocked researchers because the implications go far beyond biology. It suggests the ingredients for life didn't emerge later as a lucky outcome of planetary conditions. They were embedded in the universe from the start. Life, in this view, isn't an accident. It's a feature dot. Then came the image, the one that left even hardened skeptics speechless. Deep within a cluster of high redshift galaxies, Webb found a formation too perfect to ignore. 6 galaxies arranged like petals around a central object, evenly spaced, orbiting in near unison. Scientists dubbed it the flower. They tried to dismiss its statistical fluke, gravitational lensing, quantum symmetry from early turbulence, but no natural model could replicate its symmetry. It was an astronomical sculpture, carved into fall, light from a time before Earth even existed. Some began to ask, could this be something else? A message? A marker? A cosmic breadcrumb trail designed to be seen only by those capable of understanding it? And finally, perhaps the most unsettling theory of all, that our observations themselves are altering the universe. Known in quantum physics as the observer effect, it suggests that measurement can change the outcome. But what if this principle extends far beyond particles? What if the universe is somehow aware, responsive to our gaze? Some fringe physicists now believe that building Webb and aiming it at the cosmos with this level of clarity didn't just reveal secrets, it triggered something. Patterns in the data appear to shift depending on how and when they're processed. Some images subtly change over time, as if the cosmos is reacting. If true, it means we're not just spectators. We're participants, collaborators in the very unfolding of the universe we seek to understand.